Hey guys, it's Mr. Brian again. So here I am with another video for you for our math program, our online math program, Prodigy. I've been looking here, tracking how you guys are doing, and I've been noticing you're having problems with this particular kind of problem. It's problem number 18. So let me show it to you so that I can address it and help you out with it so that you won't have any more trouble as you go on through Prodigy. Okay, this is the problem. It says problem number 18. Fill in the missing fraction. The sum has been reduced to lowest terms. Reduce your answer. So it's 8/6 plus something equals 31/12. Okay? All right, so we're going to set this aside. And where I would begin is I would write the problem first. Okay, so the problem is 8/6 plus a fraction equals this fraction. Okay? So where I want to start is, first of all, this is bugging me that this is an improper fraction here and that's an improper fraction there. So I want to change those to mixed numbers. Okay? So change improper fractions to mixed numbers. Okay, so 8/6. So the way I taught you guys to do this is you ask yourself, how many of these in there? So how many 6s in 8? There's only 1 6 in 8, and you got 2 left over to get to 8 and over 6. It's over 6 because that's the denominator, okay? But then I look at 2 6, and I know it's a proper fraction, but that can be reduced. And so 2 and 6 have 2 in common. So I'm going to reduce both of them by 2. 2 divided by 2 is 1. And 6 divided by 2 is 3. So really, my reduced answer should be 1 1/3. Okay? I'm going to do the same thing with this other improper fraction here. So 31/12. Again, I'm going to follow the same steps. How many 12s in 31? Well, 2 times 12 is 24, so there's 2. 3 times 12 is 36. That's too many. I can't go over. So then I got to do some math because I know 2 times 12 is 24, but then I got 31 here, so how many are left over? So 31 minus 24, I'm going to borrow here, and this is 7. So there's 7 left over, so that means my numerator is going to be a 7, and my denominator is going to match my old denominator, which is a 12. And unlike the problem on top here, this 2 6, I don't have to reduce 7/12 because I can't reduce it. They don't have anything in common. So this is actually going to be my reduced answer also. So that means this 8/6 is now this 1 1/3, and this 31/12 is now 2 7/12. So I'm going to rewrite the problem using my new mixed numbers. So now I have 1 1/3 plus a fraction equals 2 7/12. Okay, so this is my new problem with mixed numbers here. So 1 1/3 plus something equals this much, okay? So if I want to figure out how much this is, what I need to do is take the part from the whole to give me the other part, because supposedly this part plus this part equals this whole. So I should be able to just take this part from this whole to get this part. So I'm going to label this part 1, and label this part 2, and label this whole. Okay, so I should be able to take part 1 from the whole to get part 2. So that means I'm doing subtraction, because if I'm taking away, I'm subtracting. So it's 2 7/12 minus 1 1/3. And I'm going to label this 2. I'm going to write whole here, and I'm going to write part 1 here. Now, I said I'm subtracting. Okay, I can't subtract this because I have a problem here. And the problem is that my denominators don't match. So I can't subtract because my denominators don't match. So to get these to match, I have to do the greatest common factor, or find the greatest common factor. No, the least common denominator, excuse me, sorry. The least common denominator for 12 and 3. So the first number that they both go into is 12, actually. So I'm going to write 12 here. I'm going to write 12 here. That's my LCD, my least common denominator, LCD. Okay? Now I'm going to move my whole numbers. So I'm going to move this 2 over here. And I'm going to move this 1 over here. And now there's some math I've got to do here. So now I got to think, 12 times what makes this 12? Oh, it's 1, okay? So then 7 times 1 should be 7. So this numerator is now 7. And then I got to do the same thing down here. 3 times what number makes this 12? Oh, I know that's 4. So then 1 times 4 is 4. So this numerator is 4. Now I have the green light because I have matching denominators. So now I can go ahead and subtract. Before I couldn't subtract because I had a 12 and a 3. Now I have two 12s and I have numerators. So 7 minus 4 is 3 over 12. And 2 take away 1 is 1 because we were subtracting. So 7 minus 4 is 3. I keep the same denominator. 2 minus 1 is 1. But then I look at 3 12ths, and I know that's a proper fraction, but it can be reduced. And I know 3 and 12 have 3 in common. So I reduce by 3, and I get 1 over 4. So my ultimate answer should be 1 1/4. This is my final. This answers the question. Okay. So supposedly 1 1/4, which is now part 2. That's what I didn't have. Now I know it's part 2. So supposedly if I go back, I should be able to plug in this 1 1/4 here in the original problem, right? Or here in my mixed number problem, right? 1 1/3 plus part 2, which now we know is 1 1/4, should equal 2 7/12. Okay, so I'm gonna do this in blue here. This is gonna be my check. Okay. So supposedly, part 1, which is 1 1/3, plus our new part 2 that we just discovered, right? What's that? 1 1/4 should equal our whole 2 7/12. Let's see. Let me label these. So this is part 2, and this is my whole. So I should be able to do this math problem. This plus that should equal this. Okay, I'm going to check. This is my check, remember, because supposedly I got everything right. So let's see. So let's do 1 1/3 plus 1 1/4. This time we're adding them because the original problem said you have to add. Okay, but I can't add again because I have different denominators. Now 3 and 4, the least common denominator they have in common, the first number that they both go into is 12. Okay, I'm going to move my whole numbers, my 1 and my 1. I'm going to switch colors just for this so you guys can see the math that we're doing. Okay, now 4 times 3 makes 12. So then 1 times this 3 makes 3. And then 3 times 4 makes this 12. So 1 times 4 makes 4. Now I can add for sure because I got a 12 and a 12. I got matching denominators. 4 and 3 is 7 over 12. And 1 and 1 whole is 2 wholes. And look, this all matches what we said here. And it matches also here, which remember came from this, which is that. Okay, I know it's a lot of work there, but it actually works. I'm actually going to show you how to do this in less steps, but it should make more sense.